So this is the Unit 7 seminar on quadratic equations. The first half of the seminar, we're going to concentrate on rules working with radicals. Now, I know that's a concept that a lot of people struggle with, and we are going to make a clear distinction. We're not working with exponents or powers of radical numbers. We're actually working with the radicals themselves, okay? That's going to be the first half of the seminar. The reason we're doing this is because the second half of the seminar is about solving quadratic equations. That's what we did in grade 10. So there's two ways of solving quadratic equations. Completing the square, which we are going to review today. That might be a concept that's a vague memory right now. But the second main concept is the quadratic formula. And in the quadratic formula, you have a radical expression, the b squared minus 4ac. And this part of the quadratic formula is actually called the discriminant. You might remember that from last year. So we need to learn how to properly deal with radicals if you're going to be able to master this concept, the quadratic formula. Because we are going to take it a step further, it is going to be a little bit harder than last year. Now, just a reminder, there were three cases involving the discriminant. So when d was greater than 0, when d is greater than 0, that means that we have two distinct x-intercepts, two different x-intercepts, so that means two different solutions. When d is equal to 0, that means we have two equal real roots. That means that there's only one x-intercept. And when d is less than or equal to 0, there are no x-intercepts, and your graph is kind of floating in midair. Those were the three situations we learned about last year. And remember that the quadratic formula is used to factor equations that cannot be factored using the trial and error method. Even if you can factor using the trial and error method, you can apply the quadratic formula to basically any quadratic expression. However, it's just easier to factor with trial and error when you can. I'll give you a second to copy that down. Yeah, next week. Okay, so let's go to full screen. I'm highlighting everywhere. Okay, so now we're going to focus on radical rules. So the first concept is going to be converting from an entire radical to a mixed radical. Now, an entire radical means a radical that has not been simplified. So where everything is underneath the radical sign. So we need to learn how to convert from an entire radical to a mixed radical if we're going to simplify radical expressions, which means adding, subtracting, multiplying. So reviewed this a little in grade 10. But first of all, we're going to break down that number 40 into prime numbers, numbers that cannot be broken down further. So first of all, 40 can be rewritten as 4 times 10. And I can now rewrite both those numbers. So 4 can be rewritten as 2 times 2. 10 can be expressed as 2 times 5. Now, I can take a pair of numbers outside of the radical sign. And just to review the concept of radical numbers, if this is the whole number 2, radical 2 or root 2 is like splitting this number in half. And each half represents root 2, another root 2. So 2 root 2's together makes the whole number 2. Okay? So because of that, we need to take one pair, or as many pairs as we have on the outside, So both pairs make a whole number 2 on the outside of the radical, and underneath the radical we're left with 5 times 2. There aren't any more pairs, so I can combine those numbers. 2 times 5 is 10. So root 40 is equivalent to 2 root 10. Now that you are seniors and you are definitely going on to grade 12 mathematics, you have to express all your answers in terms of mixed radicals all the time. Okay? Let's try a few more, or one more. Root 75. Can someone tell me 2 numbers that multiply to 75? You don't have to break it down completely, but 2 numbers that multiply to 75. Suleika? 25 and 3? Good. 25 times 3. Remember, you need 3/4 to get 75 cents, so 25 times 3. Now, the only number that's not a prime number is the 25, so we can break down the 25 into 5 times 5. So I have 5 times 5 times 3. The 5, radical 5 and radical 5 make the whole number 5. And I'm left with root 3. And that's my final answer. So the beginning of your unit guide starts off with this very simple exercise, and then we move on to simplifying radical expressions. So whenever you're combining radicals, you have to make sure to convert your questions first. So this is example number 2. 3 root 8 minus 2 root 5 plus root 32 and subtract root 20. So the only thing that is not an entire radical is that term. Even the 3 root 8 can be simplified even further. So what I'm going to do is try to break down everything except for that number, everything underneath the radical signs. So first of all, root 8 can be expressed as 2 times 2 times 2. I'm going to leave the negative 2 root 5 alone because 5 is a prime number and I can't break that down further. Now root 32. What 2 numbers multiply to 32? What 2 numbers multiply to 32? Yeah. 4 and 8. So I know that 4 breaks down into 2 times 2. 8 breaks down into 2 times 2 times 2. So we've broken up the root 32 now. And finally, root 20 just breaks down into 4 times 5, or 2 times 2 times 5. Now you don't have to always write this step down. You can do it on scrap piece of paper, but remember that you have to be able to visualize it to correctly transform from an entire radical to mixed radicals. So now I'm going to highlight my pairs of numbers, and I'm going to